Let's take a look at an example in three-dimensional space. Here we want to find the volume of this parallelepiped. It's determined by vectors u, v, and w. So we can move this around to get an idea of what this parallelepiped looks like in three-dimensional space. You could see vectors u, v, and w determining the parallelepiped, determining the dimensions of it. Okay, we want to find its volume. So to find the volume of the parallelepiped, we know that we could just take the absolute value of the determinant of the matrix composed of the three vectors that determine the parallelepiped. So in this case, vectors u, v, and w. So I'm going to take the determinant of the matrix with one column equal to vector u, one column equal to vector v, and one column equal to vector w. Okay. Now, as I've mentioned before, I've written the vectors as columns of the matrix. If you write them as rows of the matrix, you're going to get the same result because the determinant of a matrix and the determinant of its transpose are the same. Okay, so let's take the 3 by 3 determinant. So I'm going to get 2 times negative 8 minus 9. And then 4 times negative 6 minus negative 12. Give myself a little more room here. And then 3 times negative 9 minus positive 16. Since I'm expanding along that first row, I just alternate signs starting with plus, plus, minus, plus. Okay? And then we just do the arithmetic. I have 2 times negative 17 minus 4 times 6 plus 3 times negative 25. That's negative 34 minus 24 minus 75. And negative 34 minus 24 minus 75 is negative 133. Okay. Again, we get a negative. A volume, you can't have a negative volume. That negative is telling us something else, but the main number is telling us the volume of the parallelepiped. So the volume of this parallelepiped is going to be the absolute value of negative 133. Always take the absolute value of your determinant to find your area or your volume. That gives us a final answer of positive 133.